Live from the Wearable Electronics fashion capital of the world, Soho, New York City. It's Wearable Electronics with Becky Stern.
Hey everybody, welcome to the show. I'm Becky Stern. Today's May 7th. With me is Phil, Mr. Lady Ada himself. Each week we discover and explore the wonderful world of wearable electronics.
Yeah. From
the comfort of our seats and the comfort of your home.
It's a journey.
Come along with us.
Yeah.
What's on today's show?
On today's show, we're going to sell some stuff at discounted rates. LED goth, LED goth, 10% off.
LED goth.
Yeah,
this is the code you will use for your 10% off.
That's very good. It's a special Halloween episode.
Yeah.
Wearable Wednesday,
where we'll show you some cool projects from around the web and debut a new project.
Material Spotlight.
It's LEDs this time. Pixel LEDs.
All LEDs
Spoiler.
all the time.
Yeah.
Component of the week.
It's a sensor. It's one of the Flora sensors we haven't talked about yet. Components.
Okay. Questions and answers. You have questions. Becky has answers.
Yeah. So if you want to ask a question about wearable electronics, because that's what we're talking about, you can post it up in the comments and also post on Google Plus or Twitter and all throughout the week. And I collect them and we'll put them on a future show, which would make you eligible for the show's giveaway.
The giveaway this week is
Through-hole NeoPixels.
That's exciting. That's very nice.
As evidence.
All that and more on Wearable Electronics with Becky Stern.
Hooray! We have a good show.
Okay, this is a good show. It's always a good show.
I'm recovering from being sick. I know you guys tolerated my coughing last week. I'm no longer coughing as much, but it still sound like pick your favorite raspy voiced actress. Emma Stone, Scarlett Johansson.
A little Scarlett Johansson thing going on.
So it's cool. I asked our boys in Florida if I could do if they need me to do any character voiceovers. Like now's the time because I can't fake it.
All right.
I can't fake the raspy low voice.
Well, I'll do the fast talking and wheeling and dealing here. LED Goth is the code, 10% off. Flora Wearables expires tonight. Get on it.
All day long.
Yeah.
You can buy some supplies to make yourself into an LED Goth.
Okay, on the blog, every single Wednesday, I'm just going to call it, I know I've said it before, I'll say it again, we have the best selection of news, projects, and more for wearable electronics.
It's true.
There's a couple sites out there, and they'll have like costuming, or they're very focused on that. There's a couple of sites where maybe it's built around a product that's wearable. We have it all.
Right, we have it all. I would say my second favorite to the Adafruit blog is the Fashioning Technology blog. Susie does a really great job of covering industry news, but we've got DIY projects and a lot of the we stay on top of it 24/7 all year long because we just live and breathe this stuff all the time. This project, speaking of which, on the blog, if you'd like to check it out, you can learn more about the projects that we're talking about right now on the blog. Leslie posted up this DIY smartwatch by Jonathan Cook. It won some Make Magazine Arduino contest.
Yeah, he's going to Maker Faire Rome, I think, because of this.
Oh, I'll see you there, Jonathan. His DIY smartwatch, pictured yonder, is got an OLED screen. It's got Bluetooth Low Energy. It's Arduino based, and it's super neat. So if you want to learn how to make your own smartwatch, you can check out Jonathan's documentation and read more about it on the Adafruit blog. Super neat. I would like a smart pendant because I don't really wear watches. Yeah. This is another fun project that Leslie posted by a designer named Kathleen McDermott. It's like a personal space defending skirt.
Oh,
You
yeah.
got to check out the video. So like it's got a proximity sensor, and when someone comes too close to you, like on the train or whatever, it's got kind of umbrella action, and it expands out to sort of
Protects you.
protect your personal space.
We posted another neat one. I thought it was like a spiky.
Zip ties. Yeah, it was like a vest with zip ties.
Yeah, it was
with
a commuter vest.
Yeah, this is exactly. This is the same. The video is a similar premise, and it's super funny umbrella action. It's motorized too, so it like makes this noise when it's
that's
going.
cool.
I think if I made it, I'd do it manual and make it fast, like an umbrella, like whoo, because people are coming at you. You need to keep them away. But that's really cool how wearable electronics can augment your sort of like your feelings inside about how you are.
I like the shocky jacket.
Yeah.
That was neat.
I would love to wear that on a crowded train. And people would be like,
Yeah.
ow. And I'd be like, I just pretend I don't know.
Yeah. Oh,
I don't know.
all right. Next up.
This is a really cool wearable Raspberry Pi computer.
Yeah.
Someone tweeted this at us. It's got our mini keyboard, and he's got a data glove. I think it's like a mouse probably with buttons.
Yeah.
Hooked up to his glove, and then Raspberry Pi computer here, and then hacked video glasses here, and a 3D printed enclosure.
Yeah.
So you can put the screen in front of your eye. And he's looking pretty cool.
This is really neat. It combines 3D printing. It has the Adafruit electronics. We have the Pi project, which on raspberrypi.org today is featured from Noah
Our
and Pedro.
DIY glass project.
Yeah, so if you want to make your own Google Glass, you can do it. It's
Yeah.
actually possible now.
It is I like how that's the nicest thing we have to say. It's possible now.
It's possible. No one can stop
No one
you.
said it was great. If
Yeah.
everyone just said it's possible.
Yeah, even the best Google Glass is still Google
Not that
Glass.
great.
So,
Yeah.
so at least you can make it yourself. All right, next up. Hey, look, there's you.
Possible. Oh, that's me. That was me on Monday. This is this week's project. Look, I'm wearing it. Here, does it look familiar to you?
Yeah.
It's like an upgrade on our punk color project that we did last summer, which was just just red LEDs in a collar with just a battery and a potentiometer to turn them off. Now we have this project is powered by Gemma on the back, and now we have these through-hole NeoPixels, so we can use them to make these studs, and it can have patterns and animations, whereas these are just on or dim or off. You can make it really expressive. So that's a really fun project upgrade if maybe you have this kit or you want to make another one, or you thought it was too simple to begin with.
Yeah.
You can get it on with some Gemma. And we have a short video after which I'll show it on the overhead.
Okay. Okay, and we're back. Okay, want to go to the overhead? Want
Yeah,
to show this
sure.
thing off?
Uh-huh.
Okay.
And you'll do some color adjustment for us. You can see we've got the through-hole NeoPixels, and they're 8 millimeters. They're not 10 millimeters, so they're slightly smaller than the ones on the previous version of this project that we did. But dainty, ladylike, and they can display all kinds of animations. I just have the color fade right now. We also have a Larson scanner. As you saw in the video, there's a Larson scanner animation that I modified from Phil B's Trinket Larson scanner glasses to work on the collar. And you can see it has a Gemma over here. I can maybe turn on this. I'll turn on this light so you can see a little better. The Gemma, and this is our 150 milliamp hour rechargeable LiPoly battery, held on here with some Velcro tape and just wrapped around. I always wrap my LiPoly batteries in gaff tape, both to protect from being like scratched or dented, but also to provide some strain relief on the wire so that you don't rip off the wire leads, which are not designed to be tugged on at all. So the circuit is underneath this part of the collar, you see, so it's sort of the battery's protected and hidden a little bit. I really recommend putting the battery on the outside of the collar. Not that this project is really like prone to shorting. You can see that like we've protected the the circuit with a piece of micro suede, which really makes it soft and cozy to wear, and you don't get poked by the circuit, by the leads of the pixels. So there's no like raw wires exposed to your skin on the inside or anything, but if you were to put the battery inside and then something were to happen, I don't know what, meteor strike, EMP blast, you don't want this touching your skin. And like on a pet or something, if you wanted to make this for your pet, like, you know, we're not liable if you get burned, but but like, yeah, I would not put, I wouldn't buckle. Anytime there's a LiPoly battery in a project, you want to keep it so that you could get it away from you really fast, just in case something goes wrong and it heats up. Because if they're shorted, they can. We have circuit protection to sort of prevent that from happening, but if the wires in here were to short, it might get hot for a second, and you can like, oh, God, it's hot, and get it away from your body. Or your pet's body. And of course, never leave a pet unattended while wearing electronics you made. Never.
And so you have some build photos here.
I do. Since the video is, you know, not talking, so I wanted to talk a little bit more about this project. Unlike this one with the regular LEDs, the holes are cut laterally along the line of the collar, and so that all 4 legs of the NeoPixel can slide through. It grips it quite firmly. And then if you want to go to the next picture, on the inside, the circuit's a little bit more complicated, obviously, because they're addressable. So like power is up and ground is down, and then data is out. So the data chains into one pixel, then out to the next. And we made a power line across one edge and a ground bus along the other. And so that they're all, and then sort of like bent the power leads over and made it continuous.
Oh, that's clever.
So there's 3. So in here, they're all wired in parallel. And so like just power and ground, and here you've got power and ground and signal.
Because that has data, because you can control them.
Yeah.
This one is just on or off.
Right.
That's it.
And we have a potentiometer to make them dimmer, but it's all just power, no
So this is those new smart collars I've been hearing about.
Smart collars, yeah. And you could, you know, it'd be an easy upgrade for this. We did it with 5 because that's how many come we sell 5 at a time, but it would be really easy to add 5 more. My neck is pretty small too, so I might put them a little closer together if I were to do 10, but you could do 10 to go all the way around. And another cool mod you could do would be to add a sensor. So if you got like the Gemma sensor pack, and then these through-hole NeoPixels, you could make it so that like it changes the animation to be faster when you dance harder if you put the vibration sensor on it, or you could add a knob to control the color. It's a really basic project that lets you build on top of it. So.
Yeah, I like you get this anime thing going. It's cool.
Yeah, this is like dressed up Becky. I know that Lamore, like, this is a project that Lamore made when she was in school and like wore out to the club and stuff.
Yeah.
I'm just such a poser goth kid. Like, I mean, I had all of the goth feelings inside me, but I never made it to the rave. So this is really this is what I'm being for Halloween or something.
Okay, that's great.
It's not real Becky, but it's fun. I had a fun time doing this.
No, it looks great. It's a good look.
There's only, I'm almost 30. I really got to get the like Gwen Stefani buns like out before I turn 30, I think.
Code LOADGOTH, buy it, dress up like Becky. Okay.
You can get 10% off the materials for this project, which is it's a pretty economical parts list. Gemma, battery, 5 NeoPixels, 10 if you want to go crazy. So it's not even that. It's a pretty inexpensive NeoPixel project as far as they go. You can use Trinket too.
Okay, material spotlight.
We're going to talk more about these. These
breadboardable NeoPixels are awesome, so this is why they're so nice. We're talking about them twice.
We're talking about them twice. I have a demo actually for the overhead, and it's powered by Trinket. So you can use Trinket for this project. I just use Gemma because I got a million Gemmas at my desk, and like, hey. So they come 5 in a package. They have 4 pins. Here I have them in a breadboard. So power and ground are these center 2 pins. Data in is the far left pin, and data out is the far right pin. So I have data out going to the next pixel's data in, and they're bright. They operate at 5 volts. Unlike our sewable NeoPixels or the NeoPixel strip, they do not have support components inside, the resistors and capacitors. So when you use them, you should read the NeoPixel Uber guide. And if you're doing some kind of architectural installation or you're using a lot of these, you definitely will need to heed the resistor on the incoming data line and capacitor on your power supply advice from Phil B. If you're powering these off of the wall. If you're just using a handful of them on battery power, we had good results. But definitely breadboard your circuit before you put them in your collar, because like, what if one of them doesn't work?
Okay.
And you have to take it out. But they're really cool. I actually printed out some cheat sheets about these two. They're actually RGB instead of GRB, like our 5050 surface mount ones. So in the library, whenever you use any of the sample NeoPixel code library, it's well documented up top, but you have to switch a little variable from GRB to RGB so that the colors get addressed properly. Otherwise, you'll be like, why is it turning green when I wanted it to be red?
Yeah.
But other than that, they're the same as the NeoPixels in terms of communicating with them with code. So you can use any of our, like the code you saw in the video was the mixture of the Larson scanner code that I modified from the Trinket glasses, and also the sparkle random light up animation from the NeoPixel bangle bracelet. So lots of NeoPixel animations you can port to here. Here's a diagram showing the breakout of how they work, and they have a flat side to keep you knowing which side is which, so it's important they all face the same way. But they're really fun, and I'm glad that we now have these in a through-hole package, because like often people are like, I really love NeoPixels, but I need to diffuse it in my application, and you can put these inside plush toys the same as you could sewable NeoPixels, and they'd already have a little bit of built-in diffusion to help distance the light source from wherever you want it to shine.
Also
through.
from the breadboard, easier to just pick.
Yeah, you plug them if you're a breadboard person, which I don't know, whatever.
Yeah,
Most of my projects aren't breadboard.
Yeah, you could put them on perma-protos, all sorts of things.
Yeah, so they're really fun. You can use them for indicator LEDs on your next Arduino project.
Okay, you can get them for 10% off. Code is LEDGoth, 10% off. For wearables category,
they're
expires
8 millimeters.
Yep. Okay, component of the week.
I dug back in the archives and I was like, we didn't cover this one yet.
Yeah, we didn't.
This is the Flora Lux sensor. It measures light both in...
It senses lux.
Lux. It reminds me of Star Trek for some reason, the word lux. Like lore, like Data's twin.
Lore is one, and then there's, I think, there was a science fiction show where I think it was called Lux or Lax or something.
There's also a DAX, and what's Deep Space Nine is?
DAX.
DAX.
Yeah.
Yeah, I like Star Trek, everybody. This is the same as it's the same TSL 2561 light sensor that's on our breadboardable version that has 5-volt circuitry on it for use with regular 5-volt Arduinos. And this one, it's just ported over to our Flora size package. Actually, we have a little video for this one too.
Oh, we have a full video that explains exactly what this does.
Yeah,
that's great.
Today on Wearable Wednesday, we're getting started with the Flora luminosity sensor. It's the latest in our line of popular sensor breakouts that we've brought over to the Flora PCB design, which is round with easy to sew through pads. And I've just got it hooked up to the computer where I've downloaded the library for this sensor, and I have the sample sketch running, and it's spitting out light values to the serial port. And what's really cool about these I2C sensors is that they have 2 sets of data lines, so you can easily daisy chain them together with conductive thread. And this light sensor will actually break out the infrared and visible sections of the spectrum, so you can make your project react to light you do see, light you don't see, or a combination thereof. So if you make a project, we would love to see it on our weekly show and tell on Google+, and don't forget to subscribe to our channel here on YouTube.
Okay, we're back, and here we are.
Very cool. So you can use this sensor with Flora. You can't use it with Gemma because it's a digital I2C sensor, but it can be daisy chained with any of our other I2C sensors. Really fun for, if you wanted to make a weather logging hat or whatever. If you wanted to diagnose your own seasonal affective disorder,
you can make it yourself.
You wear the light sensor, and then I know that like when I wore my Fitbit that had stairs, and I was having knee trouble again, I went to the doctor and I could tell him, I've been climbing 40 flights of stairs a day, and he goes, how do you know that? And I go, my Fitbit told me.
Yeah.
And he goes, that's insane, you can't do that.
You got the reverse Fitbit. Yeah.
Right, but so like this could be helpful if you if you have a suspicion about light levels affecting something about you, or your plants. Maybe you want to like find the best spot in your house to put your plants, and you can put this on your curtain.
Yeah, this is cool.
Or make any sort of like sunrise triggered
Yeah, for drawers open, senses light, it does
Anything,
something.
yeah. But it does IR too, so you can you could use it to detect IR security cameras, maybe. You're wearing it, and you write a program that just looks at the IR value.
See who's watching you.
And says like, oh, the IR value has spiked. Like there's some source of IR light that's extra. Maybe there's a camera shining IR light at you. So it's a pretty cool sensor. I would like to see what you guys make with it. So please make something with the IR, with the Lux sensor, visible and IR light.
And you go for 10% off up until midnight tonight.
Yeah.
Get on it. Questions and answers. You have questions. Becky has answers.
The prize tonight, tonight, is 5 NeoPixels. In fact, these 5 NeoPixels. And look, I tested them for you.
Tested by Becky herself. Certified
I
NeoPixels.
plugged them in. It's these very NeoPixels. The legs, therefore, might not be completely straight, but hey, they will work.
If it's not Becky certified, it's crap.
I want to make sure that everybody's prize is
That's right.
A+ quality prize.
Okay, first question is from Lewis. What would be the best microcontroller to implement into a DIY laser tag system? It would need to power like 4 LEDs, 2 IR receivers, 2 IR LEDs, and a tactical switch. Also, what should I use to attach the sensors to a person's head?
It's a very well formulated question, Lewis. I very well formulated.
Yeah.
You could use almost any microcontroller. For smallness, you could use a Flora or an Arduino Micro. I don't think a Trinket or a Gem is going to give you the kind of debugging and extra space that you might want for this kind of project.
Yeah.
But a Flora or an Arduino Micro would be perfect. You could prototype on an Uno. Those are all capable of doing exactly what you're talking about. That's not too much stress. 2 IR distance sensors and like 6 LEDs and a switch. So like three digital inputs, or possibly 2 analog inputs, 1 digital input, and 6 outputs. Yeah, I think you'd be okay.
Okay.
And you wanted to know how to attach it to his head.
Oh yeah, let's
I think
go back.
maybe if you have like a sweatband and
That's a good idea.
And you can sew it to the sweatband, or use zip ties if you're not handy with a needle and thread. Or Velcro tape is really great for attaching things. You could also if you had an old headlamp laying around, you could maybe take out the guts of the headlamp and put the sensor in there. You could also just put it on a hat and have a wire down for the battery pack in your pocket or something. It sounds like a fun project, Lewis. I would like to be updated on it.
Yeah.
You build it.
Next up, this is from Peter. I'm trying to make a basic wearable GPS logger with Flora and the wearable GPS using the inbuilt data logging. I noticed the downloaded libraries have a Flora underscore GPS log option and a normal locus underscore start option. What's the difference here?
The GPS library comes with a lot of different sample sketches, and they vary based on what microcontroller we think you're using, and because it uses the Adafruit wearable GPS, and our Ultimate GPS uses the software serial library, and depending on what version of the Arduino IDE you're using and what microcontroller you're using, they can be slightly different. So we provide a lot of different examples, like one for the Uno, one for the Leo, Nardo, and then one for the Flora. And if you look at the code, you can do like a diff on the 2 files. They're actually not that different, but there's just a couple little things. So I would say look at but I think I did use one of the regular examples, the non-Flora underscore ones, in the GPS jacket project. So that's a project to look at for sample code, in addition to what's in the library already. And then an older project we did before any of our wearable stuff was out was the GPS dog collar, and that uses I think I used a micro. No, what did I use? And a 32U4, the Atmega 32U4 breakout.
The 32U4 breakout.
Yeah, board. And so you can look at that to see that code too. But I mean, basically, they're very, very similar. Your mileage may vary depending on what microcontroller you're using. I know it's a little bit bifurcated in there.
Next up, any chance the Flora is going to have Wi-Fi or Bluetooth shields? Yes.
Yes.
Okay.
But probably Bluetooth before Wi-Fi. I'm gonna guess.
Bluetooth low energy will probably be first because it's wearable and it's low energy. Wi-Fi takes a lot of power, so you're looking at.
And so I think even
you're wearing a battery.
I bet even the Flora will be ready before Wi-Fi.
Yeah.
Flora.
The Florafona.
The Florafona. Why would you need Wi-Fi if you had cell data?
Well, let's say if you wanted to deliver a bunch of data, a lot.
Well, why wouldn't I would think that it would be better to use Bluetooth to your phone and then use your phone's Wi-Fi to do the heavy lifting for that kind of stuff.
Yeah, that's right.
So So Bluetooth and cellular, I think, are higher priority for us than Wi-Fi for
That's
wearable, because the power consumption's a pain in the butt.
Yep.
I don't like to carry around a giant battery pack in my pocket.
Next up, do you have any strategies for making good connections to regular through-hole pads with conductive thread? Will too much freight check interfere with conductivity?
Regular through-hole pads are fine for sewing. They're not really any different than the bigger pads, except that they have less space, so you're more concerned with bumping into the neighbor through-hole connector. So I would say if you're really good at stitching, you're not going to have too much issue. But we make Flora and Gemma, and our sensors all have big sewable pads that are far away from each other, so that beginners, people who might already know electronics but not know about sewing or crafts, will have a good experience, even if their stitches aren't as precise or close together as someone who's had more sewing experience. So I would say all of my conductive thread tips hold for through-hole components. Too much freight check definitely interferes with conductivity. Don't get it anywhere near the pads. So the knots should be far away from the pad, or away from the pads. The freight check should never be applied. And you know what? I've been trying to find an alternative to clear nail polish for a long time, for sealing the knots, and I haven't been able to find something that actually works better. Freight check holds my knots. Like, I'll tie the knot, I'll seal it with the freight check will dry, it'll look solid, I'll come back the next day and all my knots have sprung loose. The freight check just isn't sticky enough to hold the stainless steel in place, and it was like a bait and switch where it looked like it was going to hold, and then a day later they all came loose.
Yeah.
So and the reason that I've been trying to find alternatives is because clear nail polish is still flammable when it's dry, and that's only an issue if you cause a spark in a short. I've never actually set anything on fire ever, but yeah, it can interfere with conductivity, and I've seen people say like, "Oh, my thread connections were flaky, so I added more glue." Not good. The glue is not conductive.
Yeah.
So you want to make that physical connection with the thread, and then make the knot a little ways away and seal it separately.
Okay. Last question from Rachel. What sewable, washable, flexible material would you recommend to use as a diffuser? I've been battling.
I've used batting.
So I've used
batting.
I've used batting and white fleece, but it gets bulky by the time I diffuse NeoPixels or sequins. Even
enough to have nice, soft, even backlighting.
That's a good one.
Without the application you're asking about, Rachel, I don't know. Those two things sound great. I don't know what application you're making that is too bulky, but I have also, we've had really good luck with the white Ninja Flex. So you can go on our Thingiverse page and download some files for printing in white Ninja Flex at your local hackerspace or your buddy who has a 3D printer. And that makes an excellent diffuser. It creates a little space above the pixel without adding too much bulk, so that then the light can diffuse open. The other thing I would recommend is like needle felting. It's not quite as, if you needle felt like a little white ball,
that's a good idea, and
you put it over top of the pixel. I did a project with Moxie, the needle felting like goddess, back at Craft a while ago, where we made a pinball bumper necklace that had an LED in it that shined through the felt, and it looks great. So you could Google that, just pinball bumper necklace, and the needle felting, it creates a denser, sort of matted, hairy thing. It's denser than quilt batting, so it won't. It can diffuse without adding so much loft. Because that's what batting is supposed to do, add loft. And white fleece is rather heavy, so yeah, I would say Ninja Flex or needle felting are two new things you could try. Also, you could try the through-hole NeoPixels. Okay. But space is really the only thing that causes good diffusion. So, like when we did the sparkle skirt, I didn't pick like a. I picked like that skirt we found had a slip underneath and like a laser cut overlay. Yeah. And that's because even with, you saw we made two versions. There's a black one that's kind of gauzy, and it is points of light that are sort of like, shrouded in fabric. But the laser cut one, they shine like comes out around the cutouts. So it's not the same kind of diffusion, it's kind of dispersion, and then it only can appear behind the opaque laser cut thing. So you might try to like, it's counterintuitive, but if you put something opaque in front of the pixel, the light bleeds out around it and you've got cutouts, then it creates this cool like halo effect. But really physical space is your best friend when it comes to diffusion. Okay.
Speaking of best friends and physical space, let's give away a prize. Someone's gonna win.
I know. Okay, so all of you.
How do they ask questions? Because that's the question I have.
You can ask questions in the YouTube comments or on the blog comments. Basically, wherever you are watching this video, you see a box where you can type. That's where you can ask a question. and I will find it. Google Plus is
good advice.
fine on the blog, Twitter. My desk is near the window, so carrier pigeon.
Yeah. Okay.
And then what I do is everybody who asks a question, I put your question on a piece of paper and I put it in this bin, and I'm going to draw a name, and that person whose question was answered today will get these 5 through-hole NeoPixels. The winner is, it's Liz. Congratulations, Liz.
All right, Liz.
You are now the fine new owner of these 5 through-hole NeoPixels. And I can't even see them. I put them in front of my black shirt.
There's the ones over there.
They're everywhere. Liz, you can email support at adafruit.com to claim your prize. I'll also write you a message on YouTube.
That's right.
And the rest of you who didn't win, if you would like to buy some wearable electronics, you can get 10% off for the rest of the day with code LEDGOTH in celebration of our punk collar.
Yeah.
Okay.
Well, that's the show. We'll see everybody tonight at 7:30 Eastern Standard Time for Show and Tell. 8 p.m. Eastern Standard Time for Ask an Engineer. And we'll be here next week.
Next week we'll have a new pick and place machine.
Yeah, I might show up like any second now.
Okay, thanks so much for watching, guys.
More machines to make more of these things.
Yeah. Submit your questions. I'll see you next week.
Bye-bye.
Bye.